Welcome to this video, and in this video we're going to prove this. Okay, so what is special about this question? Okay, so what is wrong, I mean not wrong, but what is that something special or inordinary about this question? This question may look a little ordinary type, but when you get your brain around it, then you will see that it won't be solved by the method that might come in your mind at first. Okay, so at first what comes in actually the mind is that you use the formula of this cosine A minus B. Okay, so this is actually the value of cosine 15. So if you derive the value of cosine 15 using cosine the difference formula, difference of angles, then actually you get this value, square root of 6 plus the square root of 2 divided by 4. Okay, you'll get this value. Both of them are the same thing. Okay, their decimal approximation is the same thing, so I write here that this is the same thing as a square root of 6 plus a square root of 2 divided by 4. Okay, even though I've written this equal, but I'm not going to prove this. Okay, because this is easy to prove. Just use the formula of cosine A minus B, you'll get this thing. Okay, so the decimal approximation is equal, but the form is not equal here. Okay, so and if you do any kind of other type of algebra to make this equal to this, you won't be able to do it. Okay, this is a little hard, and the method that we use is, this is cosine 15, and we're going to use the half angle formula, which will be cosine 30 degree over 2, and furthermore cosine A over 2 is plus or minus the square root of 1 plus cosine A, which is 30 in this case, divided by 2. So this is going to be I'm going to choose now the plus sign because it is cosine 15. This is in the first quadrant, so choosing, and cosine is positive in the first quadrant, so choosing positive sign. So if I choose positive sign, this is going to be 1 plus cosine 30, which is square root of 3 over 2 all divided by 2. Solving this further will get us square root of, this is going to be 2 plus the square root of 3 divided by 4. If you take the square root, just simplify this, this is going to be equal to this. If you take the square root, it is going to be equal to square root of 2 plus the square root of 3 divided by 2. So indeed, this thing is equal to this. So if you go with this approach, then you will be able to prove this. Okay, prove this thing in this form. This is the same thing as this. The decimal expansion or decimal approximation is the same thing, but the form is different, as you can see. Okay, so yeah, so this is what was special about this question. So we have done this question. Now I'm going to give you a second question, and the second question is pretty much similar to this one. Okay, so let me write down the second question. The second question is, prove what? Prove that square root of 2 plus square root of 3 over 2 is equal to square root of 6 plus the square root of 2 divided by 4. You have to prove this then. Okay, so I'm not going to write the equal to sign over here because the question has been written in the second number question. Okay, so try this out. If you have the clue to solve it now. Okay, how do you prove this? So there are many ways to prove it, but I'm going to show you two ways. The first way is using trig identities. Trig identity. Okay, if you use the same trig identity which I harnessed right now, which I used right now, you will be able to prove the equality. Okay, there's another method algebraically. We're going to do algebraically as well, but later. For now, let's do it with trig identity. So you might have the clue how you do it, because okay, for solving using trig identity, you need to know that this thing is cosine 15. Okay, but we know that this is cosine 15, so we're going to write this as cosine 15 is, okay, so we have we had this and the square root of 2 plus the square root of 3 divided by 2. Are you getting this? This is cosine 15 because we saw it just now. If you don't know that this is cosine 15, I don't guess you'll be able to solve it using trig identity. Okay, if you know that this is cosine 15, then only you'll be able to solve it using trig identity. And now, as you already might know, if we go with the sum and difference identity, then we will be able to prove this thing. Okay, so you can write cosine 15 as this, use the difference identity, so it is going to be cosine 45 cosine 30 plus sine 45 and sine 30. Okay, solve it further. Cosine 45 will be this, cosine 30 will be root 3 over 2, sine 45 is going to be 1 over square root of 2, I'm sorry, not plus, this is product, sine 30 is just half, so solving this little more will get you square root of 3 divided by 2 root 2 plus 1 over 2 root 2. If you do this, this will be square root of 3 plus 1 divided by 2 root 2. And you might say, you've got the value. Yes, you got the value, but this doesn't look similar to this one. Then actually, it is similar to this. Okay, using simple algebra or simple arithmetic, you can send this from this to this. Okay, so I'm gonna wrap this up now and do this thing above here. Okay, so let's solve this thing. So square root of 3 plus 1 divided by 2 root 2. So what do you have here? On the denominator we have 4. So to make it 4, I have to make this 2, square root of 2. So we have to make square root of 2 as 2. So multiply by square root of 2 on both sides. Okay, so what this will be equal to now? This will be square root of 6 plus the square root of 2 divided by 4, because this is 2 and then 2 times 2 will get you this. So indeed, we have proved that this thing is equal to this. So how did we approach this question? We approached this question using sum and difference identity. Okay, so and this thing we get the value of cosine 15 using the half number identity. We get the value of cosine 15 of this thing. I mean this value. Okay, we get cosine 15 equal to this value if you use the difference identity. So this is what we observe and we prove. So this is using half number identity. This is using difference identity. Okay, so it might be like in advance, if you know that this is cosine 15, then you will be able to prove it using this method. Okay, but what if you don't know that this is cosine 15? How do you approach this question? Then there is another method, algebraic method, which I'm gonna prove now. Okay, so let's use algebraic method. Now, let's prove this thing using simple algebra. It's not going to be simple algebra. We're going to have lots of algebraic steps here. So algebraic method. Algebraic method. So there's going to be a lot of background noise right now, I know. Algebraic method. So we have the thing that we need to worry about is on the numerator. In the numerator we have something extraordinary. I mean, yeah, something hard, messy. So yeah, so we have the square root of 2 plus the square root of 3 on the numerator. We're going to change that to what? We have the square root sign here. Do you have the square root sign here on both of them? Okay, so my question was, there is the square root sign on this, but do you have the square root sign of all of this business here, right over here? No, we don't. I mean, we have singular square roots, but it is not the square root of the whole thing. Okay, they are separated. So how can we separate this into two numbers, a and b? To write a plus b. Okay, this needs to be separated into two numbers, a plus b. And let's suppose that both a and b are radicals. A and b are radicals. Let's suppose this from the beginning. We know this from the beginning that a and b are radicals. We know in advance that a and b are radicals. Meaning square root sign is there. Okay, so it means if you write without the square root sign, then both of them will be irrational number, a radical, not a pretty number like 2. Okay, A and B are radicals. And then if there are two radicals, let's say the square root of 2, and I'm showing you as a specific example. If you have this, let's discuss what happens if you square this. Let's discuss what happens if you square this. So what's going to happen? You tell me. It's going to be square root of 2 plus the square root of 3 plus 2 maybe. So a is the square root of 2 multiplied by square root of 3. Okay, so I wanted to do it in just one line, but I didn't save space for understanding. 2 plus 3, 5 plus 2 root 6. Okay, it is going to be this. So what's the observation? 1 will be the square root of this, which will be a good number, which will be a pretty number, which is a rational number. Does that make sense? Again, the square of this, which will be again a rational number. Then here will be radical. Here will be radical. This is our observation. So square root will be there. So this is the observation that we make. So what my next approach is that I want to make this, somehow turn this into a square number, a good number. Does that make sense? I want to make this a square number. So what I have been trying to do here, make this thing underneath. Okay, so this is incomplete right now, I know. 2 plus the square root of 3. I want to make this a perfect square. I want to make it a perfect square. Okay, we have a square sign on it. Why do we want to make this a perfect square? Then we will be able to get rid of the square root. Does that make sense? So square root is square root. This thing I want to have this in terms of perfect square. Perfect square. Okay, good. Okay, so and what I know now, what I know is that if I take the square root, okay, and I have supposed that a and b are two radicals, because here you can see that there are two radicals here. Does that make sense? A and b are two radicals. It means if we square it, let's expand this. Okay, let's don't take the square root. I'm not going to write that this is a plus b. I'm going to expand the inner part. So if we expand this, what is going to be? It's going to be a squared plus b squared, and the a squared plus b squared will be a good number, and 2ab, this will be the radical. Does that make sense? So this is going to be now on this side, on the right hand side, this is going to be a squared plus b squared plus 2ab square root of 2 plus square root of 3. This is rational number. Why is a rational number? Because if you have two radicals, then the a squared plus b squared part will be a good number, will be a rational number. But this part will be radical. Does that make sense? So you can equate here that a squared plus b squared is equal to 2. Does that make sense? The radical part will be equal to the radical part, because the distinction is made here that one is rational and one is radical. So radical will be equal to radical will be equal to the radical, rational will be equal to the rational. Does that make sense? So 2ab will be equal to square root of 3. This much progress we made, such that we have two equations, two unknowns. Good. Good. Now, the next step. What's the next step? Now, the next leap is that we want to find what those A and B's are, because this is what matters here in this case. Okay, using this method, if we use this method, we have to know what those numbers are. We want to find out what A and B's are. So let's solve for A and B. If you solve for A here, then A will be equal to square root of 3 over 2B. Does that make sense? This is what A is. Let's plug this into this equation. So if we plug this in the first equation, we're going to have square root of 3 over 2B whole squared, which is A here, plus B squared. So B squared is equal to 2. Does it make sense till here? So solving this further will give us what? 3 over 4B squared plus B squared is equal to 2. Easy till this step. Okay, great. What can we do now? Okay, so now the problem is yelling at you what to do next. Okay, so let's do whatever that is saying to you. So what does it say? It says this will be 3 plus 4b to the power 4 divided by 4b squared. This is what it throws at us. Okay, this is what it is throwing us. 4b squared, multiply these two, 4b to the power 4, 3. This will be equal to 2. This will be 3 plus 4b to the power 4 is equal to 8b squared, plus put this on this side because we have something that we can solve using quadratic. 4b to the power 4 minus 8b squared plus 3 is equal to 0. This is what you've got here. And there are too much step here, but are still making some progress, it looks. Okay, now what? Let's solve this. 12, so 4b to the power 4 minus 6b squared minus, okay, second, I'm going to wrap this up. Plus 2b squared plus 3 is equal to 0. This is what you can expand this now, because how you can write this? Because if you multiply this out, it gives you 12. So you have to get, by doing the operation, we have to get minus 8. We do get minus 8. By multiplying this, we have to get positive 12. We do get positive 12. So this is it. Now let's have common 2b squared here. So if you have 2b squared common, this will be 2b squared minus 3, okay, minus, let's have one common, so it will be 2b squared minus 3 is equal to 0. So we get what equation from this? 2b squared minus 1 times 2b squared minus 3 is equal to 0. There's too much algebra, I told you. Okay, so this is what we got. Let's solve for b. Let's solve for b's. So 2b squared will be 1 if you use this part, okay, which means b will be plus or minus square root, okay, let's write this 1 over square root of 2. It will be this thing, 1 over 2, take the square root, plus or minus 1 over square root of 2.